Hello. In this unit, I want to talk about some programming concepts. We've looked a little already at how programmers operate, how programming languages work. But I want to take a look at how we use these languages to design code, the logic behind designing code. When we start talking about logic, especially when we want to describe logic, we describe relationships and choices, we use a tool called a flowchart. And programming is a set of logical steps to solve a problem. A flowchart is a way to draw a picture of that. We have a set of blocks of different shapes, and they mean different things. Some programmers love flowcharts and find them helpful. Other programmers hate them. Most IS managers and development managers usually insist on flowcharting logic. It's the only way after you've written software to remember how the software really works. So here's an example. Let's say our challenge is, do I skip lunch or eat lunch today? I want to arrive at that decision. I want to know what to do. The first thing I need is an algorithm. I need a way to make that decision. I need a process. How will I decide whether to eat lunch or skip lunch? I choose, as my algorithm, I'll flip a coin, which is another way of saying I'll make a completely random choice. So how would I then develop logic for that process? Well, I'd start. In the beginning, the little circle is always either a starting or ending point. And then I'd take my first action. The first instruction is flip a coin. This is a really simple algorithm here. So I'd flip that coin. Then I have a decision to make. I have to compare the coin and ask myself, is it heads or tails? If it's tails, I'll skip lunch. If it's heads, I'll eat lunch. What I've just given you is a pretty straightforward example of a software. This is the kind of thinking that programmers have to do. And they approach these, and there's different kinds of logic that they use to approach problems. The simplest and most common is called sequential logic. I follow each step in the order. There's no repetition. All the arrows point the same way. I'm always going from the top to the bottom of this software code. I never go back and repeat anything. This is a very simple and easy to follow. Now, this code could be 1,000 lines long. This code could be 200,000 lines long. But fundamentally, I'm just working each step at a time. Sequential logic. It's actually pretty rare because most problems can't be solved sequentially. I may have to repeat some step over and over again, and then I use something called looping logic. In other words, I may have to keep checking that is this right, is this right, is this right? Finally, yes, it's right, and then I go off and do something else. Or I may say, repeat this process 12 times. Maybe I have 12 different sets of data, and I want to do the same thing to each of those 12 sets. So I write code that's looping logic with a repetition of 12. So this is what it would look like on that particular flow chart. I keep flipping the coin, or I keep doing whatever it is I'm doing. Is the problem solved? No. So if the problem's not solved, I'm going to go back over and over and over again. Finally, I'll get a yes, and then I move on to other parts of the program. So that is looping logic. Then there's decision-making logic. This is when I compare the results of something and I decide which way to change. The software doesn't know before it reaches this step what it's going to do. So I get to a point where I have to make a decision. Inside this little sideways diamond-shaped block here is the symbol for a decision. Typically, a decision is made by comparing two things. Are they equal or are they not equal? I use usually some math, a math operation of some kind to do that. And then that then tells the software which way to go in this case. And that lets software be dynamic and react to different situations. So that's decision-making logic. Now, before we go and leave this behind, I want to take a look at some decisions that are made on large software and systems projects. So let's think about these in terms of how you would write a flow chart for these things. This is my favorite tool for project design. This should be given to all brand new system developers. It should be given to their managers and to their users. It's a model that says there are 3 things you can require in software, software development. I can want that software very quickly. I want it fast. I can want the software to be very high quality. I want it good. And I can want the software to be very inexpensive. I want it cheap. The model is I can usually only get one of those. At best, I can get 2. So pick 2. You cannot have them all. If I'm in a real hurry and I want that software right away, I can get software right away. And I want it to be good. I want high quality software and I want it fast. I'm going to have to hire lots and lots of very skilled programmers and lots of managers to supervise them to get them very quickly through producing this great piece of software. That's not going to be cheap. If I want the software cheap and fast, I can do it by simply cutting a lot of corners. I'll throw something together. It's not going to be good. If I want it fast, if I want it good and I want it cheap, I can probably get there, but it's going to take me forever. I'm going to have to wait for programmers to have some extra time, and it could take me years to get what I wanted. So this is a standard model that shows the basic trade-offs in software development. You could write a flowchart showing how you would make decisions based on that. Typically, if you're a software manager, your questions are things like, how much will it cost? Can I afford it at all? How long will it take? I may want to know the return on investment. Is this software really going to be worth the cost of writing it? I could want to know, when is it going to break even? When will we get paid back for all of the money that we've invested? Those are the kinds of things that managers will ask questions of. The programmers themselves usually hate to be asked these questions, but in the end, if you can't get good answers, it's very difficult to convince anyone to fund the development of a new piece of software. Now, you can always assume that you can buy what you want. There's plenty of hardware and plenty of software out there if you just want to buy it. The uncertainty comes in the design and the implementation. How do I bring all that hardware and software together in a new way to do something new? That's the place where software developers and project managers earn their money. If you have any questions, I'd suggest that you watch this video again as often as you need to. I would also suggest you go to the website, that you read the additional recommended readings for the unit, and that you take a shot at answering the unit questions. Thank you.